Alright guys, I'm going to make some additional comments about our last lesson in Math 0106 Lesson 5. This is just some little things I've noticed when I was editing the video, what to look out for. So this was one of the problems we did, and I was showing you guys how to cancel things out. And what I did actually is I gave you two examples of how I canceled out. So here I believe I did 14 with 35 and said they're both divisible by 7, whereas here I did 14 and 16 and they're both divisible by 2. So I was just showing you different ways of doing this. But there is another way of doing this. And the reason why I'm showing you this is if what I was doing earlier, you're still struggling with it, there is another way to do this. And I think that in the grand scheme, this is actually what is going on, and I think it helps you to, if you're struggling, it really helps you to see what is occurring in this process. So what I'm going to do is I'm actually going to rewrite everything as I'm going to write them as the prime factorization of 14, 45, 12, 27, 16, and 35. So 14 is 2 times 7. 45, now we know 45 is 9 times 5, but 9 is 3 times 3. So 3 times 3 times 5, right? So those 3 times 3 is 9, 9 times 5 is 45. 12 is 4 times 3, but 4 is 2 times 2, so we have 2 times 2 times 3. And if you need to write it twice in order to get it, if you need to go 4 times 3 and then go 2 times 2 times 3, you can. Sorry, this pen is a little big, it's hard. The ink is pretty big. Okay, anyways, 27 is 3 times 9, which is 3 times 3 times 3. You actually, I'll be honest with you, if you plan on getting through, if you have to go through like college algebra or classes of that nature, you're going to want to know that 3 times 3 times 3 is 3 to the third. That is 27. You want to start memorizing that. So if you see 27, it's nice to realize that 27 is 3 times 3 times 3. You can always derive it again. And the same thing with actually 16. 16, most people I think most people think of 16 as 4 times 4, but 4s are 2 times 2. So this is 2 times 2 times 2 times 2. In other words, 2 to the 4th is 16. You want to know that. You see 16 as 2 to the 4th in future math courses all the time, so you want to get comfortable with that. 35 is just 5 times 7. So to be clear here, what I'm doing is this is the first number, this is the second number, this is the third on the bottom, this is the first one on the bottom, this is the second one on the bottom, and this is the last one. So you can see the effect and the importance of parentheses. It helps you to categorize the information. And then what I'm going to do is I'm just going to rewrite it in order. So notice I have 1, 2, 3, 2, so 2 times 2 times 2, and then I have 1, 2, 3, 3, so I have times 3 times 3 times 3, and then I have the 5, and then I have the 7. And I'll do the same thing with the bottom. Let me choose a neutral color here. Okay, so I'm going to do the same thing on the bottom. So let's see here. So I have 1, 2, 3, 4 2s. So 1, 2, 3, 4 2s, and then I have let's see here, 1, 2, 3 3s. So 1, 2, 3 3s, and then we have the 5. We just have 1 5, and then we have the 7. Okay, color coded it to make it a little easier on the eyes to look at what's going on. But the neato thing about this is that if I write it this way, the 2's divide out, the 3's divide out, the 5's divide out, and the 7's divide out. So all I'm left with is what? All I have is 2 on the bottom, right? So remember we said when it divides out, these are technically all 1. So 1 times 1 times 1. How many times do you want to multiply 1 by itself? You're always going to get 1, and the denominator is 2. So notice that. It's the same answer. So if you really struggle, break them down to the primes and you can solve. And that's really that's why prime factorization, that's one of the usefulnesses of prime factorization. So if you're really struggling, maybe try that and see if that helps you out. Okay. The other point I wanted to make, and this was kind of, when you speak, it's funny, when you listen to yourself speak, you kind of realize how many times you say things, and you mean one thing, but you kind of say it in a different way. And as an exercise, if you want to, you should record yourself speaking and notice how many times you're like, oh, I actually kind of meant that. But as I was doing this, I made a little... It doesn't affect anything, really, but there's sort of a technicality here that I want to talk about. Usually when we talk about length and width, the longer side is the length, and the other one is the width. I even said in the video, it's kind of funny, I said in the video, I said the length of the width. But length is usually the longer one and width is the smaller one. It doesn't really matter because in math we have what's called the commutative property. So 2 times 3 and 3 times 2 actually mean the same thing, right? They're both... Well, maybe this is a philosophical question. Is 2 times 3 and 3 times 2, even though they're equal to the same thing, are they the same thing? So then maybe they're not the same thing, but they equal the same thing. So 2 times 3, 3 times 2, you can flip it. It's called the commutative property. Okay, so that I just wanted to make the comment there that technically we usually write the longer side as the length. And there was one more comment I wanted to make. Right here where I say allowing 2/3 pounds of salmon per couple. Let me write that out. That's 2/3 of... Well, I'm going to write 2/3 of couple. I know that that's not exactly what it's saying. What I want to stress here, and again, we're going to see this later on in the course, but this is a good preview. Of means to multiply, usually in math. Now, you have to read in context of the question, because sometimes you'll see the word of and it doesn't technically mean to multiply. So that's why I said 2/3 times, what was the number, 45? You can see my work here for that. So just wanted you to note that when right here where it says 2/3 of couple, and the reason why I'm saying 2/3 of couple is because the question is only talking about couples, and then you have 2/3 and it's asking you what's the amount of pounds. But the way you would do that if you see of, it's literally I'm just translating word for word, and that's going to be useful as we progress through the course. So wanted to make a comment about that. Okay, and that's about it. Again, as you watch these videos, if you notice something that isn't clear, or you notice something that I said and it sounds like I said something wrong, let me know, and I'll make a follow-up video discussing it. Oh, as I'm saying this, there was one more comment I wanted to make. This is very minor, but I said in number 19, I said that we're taking the area of the garden. What I really should have said is it's a rectangular garden, hence that's why we used area as length times width. Why am I writing it again when it's written right here? It's beyond me, but yes. So it's the fact that it's rectangular, right? Because you don't have to necessarily have a garden that's rectangular. I know that usually when we think of gardens, we think of rectangles, but I could have a triangular garden. I could have a circular garden, right? It's in the realm of possibilities. So it's the fact that it said rectangular. It's the rectangular part of the sentence that helps me know that I have to multiply 6 times 7/3, which I did right here. Okay, so hopefully that clears some things up, and I'll see you in the next video.